Hi friends, welcome back to my channel. So today we are going to discuss one more topic from the computer organization and architecture, and the topic name is cache addressing and chip select. Okay, so now I am taking one more example from this topic. So first of all, while seeing this question you may think what is this much question, like by reading itself you will get a headache. But listen, once you read the question, after writing the given terms and what to know what to find, like after knowing what to find, right, it will be very easy. And one more thing is, right, the answer will be lesser than the question. Okay, so okay, don't waste the time, let us go to the solution. So what is the question here? The memory, each structure as block set associative cache memory consists of 128 blocks. How many blocks given? First of all, I always am telling one thing, we have to write given terms. So first of all, what are the how many number of blocks? So number of blocks is that number of blocks is 138. Sorry, 128. How much? 128. And those blocks are divided into 4 block sets, which means how many sets it is divided, how many block sets it is divided into? 4, right? So which means 4 block sets. We have how many block sets? Block sets is equal to, like, it is divided into 4 block sets. Okay, and these 4 block sets we can say to this as 4-way set associative. Okay, we can say it as 4-way associative. As the blocks are divided into 4 block sets, we can say 4-way associative. 4-way set associative. Okay, and if you want to know how many number of sets are there, just we have to do number of blocks by number of sets. Sorry, 128, right? 128 by 4, that is 32 sets. Okay, so if we want to find number of sets are there, just number of block by block sets. Okay, done. So the memory is structured as block set associative. Cache memory consists of 128 blocks, and it is divided into 4 block sets. That way we have written block sets equal to 4, and the number of sets is here. Okay, main memory consists of 16,384 blocks. How many blocks main memory contains? Main memory consists of how many blocks? 16,384 blocks. Okay, how many blocks? 16,384 blocks. And also we can write this as 2 power 14. Okay, yeah. So and each block contains 256 words. Okay, how many number of words per block? Number of words per block that is equal to 256 words per one block. How many blocks are there in main memory? 16,384, and we can say write it as 2 power 14. Okay, next, and also for 2 power 8 we can write 2 power 8. Okay, just I'm writing normally. Just you have to, whenever there is given blocks or anything like that, right, what you have to do, first step is convert it into 2 powers. Okay, in the form of 2 power, write it as. Okay, next, so up to this, just you have read this much question and you have write the given terms. Okay, 20 to 25% done of your answer. And next, what the question is being asked, that is, determine how many bits are required. How many bits are required for addressing main memory? Just we need to find the bits. So for finding the bits, we need to know how many number of blocks are there and what are the number of blocks for the number of words for that block. Okay, first what we have to know, total number of words. Okay, so for finding the A question, what the question is asked, determine how many bits are required for addressing main memory. So for addressing main memory, how many bits, how can we find? We have to find the number of words are there. So for one block, number of words is 256, right? Number of words per one block, it is 256. But total blocks are 16,384. So if you multiply this and this, we will get the number of words. If we are getting the number of words, then we can write that 2 power something. So that will be the number of bits. Okay, so let us find. So what we need to find? The total number of words. 1 minute. Yeah, I think it's fine. Total words. First we need to find total words is equal to 16,000 834 into 256. That is, so after calculating this, we got 4 lakhs 309, like 43 lakhs 9,504, like this. You may be like, how this much calculation is very tough, right? That's why I'm telling, whenever they are giving anything, then just convert into 2 power something. Already we told 16,834 is nothing but 2 power 14 into 2 power 8. So it will be 2 power 14 plus 8 is 22. So we can write it as 2 power 22. This much, same value if you can observe also. So 2 power 22. Okay. So it is the total number of words. So if you want to find number of bits, just take the logarithm of this much. Logarithm of box is equal to 2 power 22, right? So 22 will be the number of bits. Number of bits is equal to 22. Just take this log of this, you will get the 22. Okay. The power which is there, right? Always that is the number of bits. As we have already solved the previous ones. Okay. Now B. Determine how many bits are needed to represent T, S and W fields. 1 minute, let me show you the question. See, what is the second question? The second part be here. Determine how many bits are needed to represent the T, S, W fields. Okay. T, what is T? Tag. S means set. W means word offset. We have to find number of bits. Same, write in the form of 2 powers, and what is there in the power? That will be the bits. First of all, T. Let me find W first. Already we know W, word offset within block. W is nothing but, already we found like how many number of words are there, words per block. You can see number of words per block is 256, right? Number of words per block is 256. We can write it as 2 power 8. So how many number of bits are there? 8. So for each block we are finding first. Okay. And next, W done. Next I am finding C. C is nothing but set. So logarithm of number of sets. How many number of sets are there? If you can see here, 32 sets. So for 32 steps, right? How many sets are there? 32 sets. 32 sets is nothing but we can write 2 power 5. That is 5 bits. And number of T, tag. Tag is nothing but total address bits. That is number of sets per block and number of words per block. That is 5 plus 8. And we have to subtract it from the total ones. What is the total? This is the one we are adding W plus S. What is the total here? 22, right? We have to subtract it. This 22 from like we have to subtract this 8, 9, 10 and 13. We have to subtract 13 from 22. Why? The formula for tag, what we need to address, that is the main total number of bits minus sets plus words, that is 22 minus 5 plus 8. That is nothing but 9 bits. Then now we can go to C part. See how much simple. So if you are writing in the notes, you can't know why we are doing all these things. So that is the main reason I am telling to read. If you read this one thing now, you don't need to write all this much in your notes and you have to take it and at the exam why this happening. If you are giving this one, then we can write as it is. But definitely we can't get the same question, right? So that's the reason I'm telling to learn. Okay. So last one. The chip select logic for a certain DRAM, okay, chip in memory system design is shown below. Okay. Assume that the memory system has 16 address lines. How many address lines are there? 16 address line, like A0, A1, A2, I think so. Denoted by A15 to A0. A0 or A10. So A0 to, I think, A0 to A15. Okay. Determine range of address in hexadecimal we have to write of the memory system that can get enabled by active high chip select CS signal. Okay. So you will be confused. First, let us see what is there in the diagram. Here is already they told A15 to A0. There are total 16 address lines. Here they have shown 1, 2, 3, 4, 5. Let us leave for the remaining. First, let us concentrate on this. From the drawing, from this diagram, what we can see, there is a AND gate. Okay. And which uses inputs as A15, A14, A13, A12, A11. With bubbles on A13 and A12. That means these two inputs are inverted. Okay. Now, so CS is equal to high when CS is equal to high. When it will be high? when A15 is equal to 1, A14 is equal to 1, A13 equal to 0, A12 equal to 0, and A11 equal to 1. Why? You can see here, because from the diagram we have written these values. Okay, next, that fixes the top 5 bits. These are the top 5 bits, and the bottom from A0 to A10 are the bottom one. So these are the top 5 bits. These are from A5 to A11. These are the top 5. What is that? 1 1 0 0 1. These are the top 5 bits. So the lower 11 bits are A10 to A0. So they can be anything. The enabled address block in the enter range where the top 5 bits are 11 0 1. So we have to find the range. Okay, we have to find the range. That is the question, right? Where is the exam that the high memory? We have to find the determined range of address. We have to find rate. I mean, that means range. So let us see. Range means there will be starting one and there will be ending one. Starting one, what will be the starting one? All will be the zeros. There are 16, right? 16 address lines. Already 1 2 3 4 5 is fixed. Okay, these 5 are fixed, but the remaining ones we don't know. First of all, let us assume all are inverted and all are normal. That's all. The minimum one will be all zeros, the maximum one will be all ones. If I take 1 1 0 0 1 are the last 5 ones, that is fixed, and 5, right? 6 7 8 9 10 11 12 13 14 15 16. Okay, this is the starting one, and we have to convert this to hexadecimal, and at the ending one 1 1 0 0 1. Okay, 5 6 7 8 9 10 11 12 13 14 15 16. These are the ending one. Okay, now, so after this, convert this into hexadecimal. This is in the binary, just convert into hexadecimal. How can we convert? Take 4 digits and convert into the hexadecimal. So after converting that, what we will get? So 0x, as it is hexadecimal, it is the symbol 0x C800 008C, and similarly 4 4 4 4. So similarly for this, F C 0x C F. That's all. This is the range from C800 to C F, and this is the 0x is nothing but the denoting. Okay, so this is the easy solution to solve this question. So let me know if you have any doubts from this question. You can comment me in the comment section. So also, if you have any suggestions, you can comment that, so that I can be modify that in my next videos. So thank you guys for watching my video, and share it to your friends if you find this video helpful, like it will be useful for them. You're thinking that it will be useful for them, then you can share this to your friends as well. And these notes will be uploaded in the LearnBuzz very shortly, and I will be providing the link in the description. Thank you.